Hello, welcome to Sergei's Physics. Today we are going to derive this equation of kinematics. 2as, acceleration by displacement, is equal to difference between square of final velocity and square of initial velocity. Let's see. What kind of movement it is? This is movement with constant acceleration. If I draw a graph how velocity changes with time, I would get something like that. Initial velocity here, final velocity here. Steepness of this increase or decrease would depend on acceleration. Acceleration is actually the gradient of this graph. This change of velocity taken during a time delta t. What distance the body actually covers during this? The distance is equal to this area under this trapezium. This area is also equal to area of this rectangle. The side of it is, you see here, from 0, and here is average velocity. Is second plus first over 2. You see, so we have one formula which we can already use for displacement. Displacement is average velocity by time, which is in turn v2 plus v1 over 2 multiplied by time taken. Second one, for acceleration. What is acceleration? By definition, this is a change in velocity over time. Change in velocity per second. What is change? What is this difference? Final minus initial over time during which this change took place. Now we have S and A, and we can just multiply them by each other. AS equals v2 minus v1 over delta t, and here v2 plus v1 over 2 delta t. Let's put this in brackets so that I'm not confused. We can see immediately that delta t cancels here, and we can multiply by 2 left and right. 2as equals 2 v2 minus v1, v2 plus v1. This expression itself, you know from algebra, is difference of squares. If you open the brackets, we get just this. v2 squared minus v1 squared. We got the formula finally. 2as equals square of final velocity minus square of initial. Fine, we derived the formula. But what is physical meaning, if there is any? Let's look at it. Because you see, velocity squared, or as, which is also meter squared over second squared, doesn't have really physical meaning. Velocity squared, there is no physical quantity having these units. But there is one, mass by velocity squared. Mass by velocity squared over 2 is kinetic energy. Let's divide left and right of this equation by 2 and multiply by mass. Let's see what happens. Acceleration, mass, distance. I divided by 2, I multiplied by mass. Multiplying by mass, mv squared, dividing by 2, and the same here. mv1 squared over 2. Am, what it is? We know that on the body, if sum of forces is acting on the body, according to second law of Newton, body moves with acceleration. So that this equation is fulfilled. Am equals to sum of all forces acting on the body. This is the force which is causing the body to accelerate. And it's here. force, sum of all forces, this is a sign sigma, means sum, multiplied by distance by which the force pushes the body. And it's equal to kinetic energy final minus kinetic energy initial. Change in kinetic energy. Force by distance is work. So we got here that work done by the sum of all forces on the body, moving it on the distances, work done by the force is equal to change of kinetic energy. Body moving with acceleration, changing its kinetic energy, and the change is equal to the work done. This law is hidden in this simple kinematics equation. Simply, if you divide by 2 left and right, multiply by mass, we see it immediately. Work is equal to change in kinetic energy. Now, let's try to use this equation to solve some simple problem. For example, we have a train which is moving with velocity 40 meters per second, and it is coming to stop over the distance of 500 meters. Initial velocity 40 meters per second. It comes to stop. What do you know about final velocity? It's 0 meters per second. It comes to stop over the distance of 500 meters. So displacement is 500 meters. The question is, with which acceleration did it move when it was stopped? This is the question. Let's draw the diagram to help us with solving the problem. That's a train with initial velocity is coming to stop over the distance 500 meters. Here is positive direction. Say this is 0 and this is x. Here is our original equation. 2as equals v2 squared minus v1 squared. We need acceleration, so let's express it from here. v2 squared minus v1 squared. I divide by 2s left and right. Here 2s would cancel, and here I divide by 2. Now I'm ready to put numbers into the expression. So final velocity is 0 squared meters per second squared, it's anyway 0, minus 40 squared meters squared second squared, divided by 2 distances, 2 multiplied by 500 meters, which is equal to 40 squared is 1600, and below we have 1000 meters. Meters would simplify. My final unit is meters per second squared, as it should be for the units of acceleration, and I have minus 1.6 meters per second squared. That's acceleration with which the train would stop. But what this minus sign means here? Well, here it's our positive direction, which we put as positive, because it's in the same direction as our x-axis. Initial velocity positive, because it's in the same direction. If we have acceleration negative, it means it's directed opposite, like that. 1.6 meters per second squared. Thank you for watching. Please subscribe to the channel and encourage me with likes. See you next time. Bye.